We have a couple of different ways that we can think about sets kind of interacting with each other, so we're going to look at those. First, we've got the complement. The complement of a set is written, whatever the set is, so in my example I've got A. The complement would be written A with a bar over the top of it. And basically it's everything that's not in the set. It is the opposite of the set. So it's all the elements that were in that universal set that we looked at before that are not in our set. So let's look at an example here. Again, I'm going to write this out in listing notation so we get some practice with that. I've got some practice for you guys to try it on the next page. But the universal set, if that was all the natural numbers, in listing notation, that's what it would look like. That's what U would be. A would be all the multiples of 5. Multiples was when we're multiplying. Think about those multiplication tables that you learned in elementary school. So the complement of A would be everything that's not in A. So out in words, that would be all the natural numbers that are not multiples of 5. If you're a visual person, what I'm going to do is I'm just going to take out all the multiples of 5. So in listing notation, we won't see 5. It'll just skip over it. We won't see 10. We won't see 15, and it would keep going. So that's our complement, everything that's not in a set. We also have what's called a subset, and then to go along with it, a proper subset. I'm going to kind of do these guys together. A subset is part of a set, basically. That's kind of like in layman terms. Is formal definition is a subset. If B is a subset of A, and order does matter. That means that we want to see if all of B is in A. So B is a subset of A if all elements of B are also in A. And we write it like this. It's a sideways U. We use a U for the universal, and we're going to turn it on the side here for the subset. It does have a bar underneath it. That's like an equal sign. That means that it can be equal. Because it has that equal sign on there. So if I'm going to come down here and I'm just going to look at number 1, so we can work at that one. We want to know if B is a subset of A. So I'm going to check these elements of B and see if they're in A. 2, 4, 6. Yep, they're all in A. So that is true. Now a proper subset, it takes a little bit more work because it's proper. If you're going to act proper, that's a little bit harder than just act it all regular. So it's harder to be a proper subset. So to be a proper subset, it starts the same. You have to have all the elements of B are also in A. So the same beginning. So this is the same, but there's something added on. And there is at least one element of A that's not in B. So that basically means B has to be smaller. You cannot be equal. So to be proper, you cannot be equal. You can't be the same set. You have to be smaller than it. And since you can't be equal, we don't put the equal sign underneath it. It's just that sideways U. We're not going to put the equal sign because you cannot be equal. So if I look at number 2 down here, I want to know if it's a proper subset. Well, 2, 4, and 6 are in there. We already knew that. And B is definitely smaller than A. B has a cardinality of 3, and A has a cardinality of 6. So that is true. All right, so let's take a little second And why don't you try 3 and 4? I'll do 5 at the end because it's that empty set, so it's kind of a little weird. But why don't you go ahead and hit pause and try 3 and 4. Let's see how you did on 3 and 4. We want to know, is A a subset of C? So are all the elements in A and C? Let's see. 1, 2, 3, 4, 5, 6. Yep. Everything that's supposed to be there is there. Now, 4 wants to know if it's a proper subset. A proper subset, notice it does not have the equal sign underneath it. That means it has to be smaller. You can even think about this being your inequalities from back in the day, where that says A has to be less than C. It's kind of faced that same way. I know it's not the same symbol, but they are facing the same way. So that's an important part of that. And so this one is not true. A is not a proper subset because they're equal. A is not smaller. You don't need that explanation there, but I'm going to put it that way. If you have questions when you're looking back over your notes and working the problems for the homework, you'll have that there as a little bit of support on why that one wasn't true. Now, this last one is kind of just a definition, abstract thinking. We've got that empty set. So we know, is the empty set a subset of B? And that is true. The empty set is actually a subset of everything. It's a subset of A, B, and C. It's a subset of the universal set. It's a subset of everything. That's because, like, everything that's, because of the definition, it would say everything that's in this empty subset has to be in B. And that's true. There's nothing in the empty subset, so therefore everything in the empty subset is also in B. And if you were like, oh, there's no way I would have gotten that. That's all right. That's why I'm here to tell you. Now you know. So now you will be able to work the homework problem.